Yeah, hi everyone. So today we are going to do this linked list question, wherein we are given a sorted linked list, two sorted linked lists, and we just have to merge them. So, like if we are given like this, if we are given like this, so two linked lists. So we need to they're in ascending order. So we need to merge them. So 2 6 7 8 and 1 3 4 something like this is given here. We need to do the output should be like 1 2 3 4 5 6 7 8 9 and 10 like that. So hope you got the idea. So this might sound trivial, but when you try to implement so if you try to see it, like you can say the brute force would be that you would iterate, so you would keep list two pointers here, L1 and L2, and whenever there is a small whenever there is if L1 is lesser than L2 and all, you need to change the pointers and stuff. So that one is a bit trickier than, like, first you might feel it's easy, but it's a little bit tricky. So here's how we can do it. So, and also, if I'll tell you to you in such a way that you can remember it also. And the thing is, you need to keep track of the pointers. So let's see how we can do that. So before this one, so let's just do this by by normal how we would do, like like a human. So if we are given these two linked lists and we want to merge it, like, one thing we can do is we can just change the arrows like this one. So for example, we have one over here. One is the smallest number, so one will point to 6. Okay, two instead of pointing to 6 will now point to 3. 3 4 is okay, 5 is okay. 5's next pointer will now point to 6 like this. 7 8 8 is the end, and we would just assign this one like this and join this one. So then we would have 1 2 3 4 5 6 7 8 9 10. So this is what we want actually. So this is the output. So in order to do this, I'll just tell you an easy step and you'll remember it easily. So first thing, what we'll do is we'll create a dummy head like this one. Okay, so we'll create a dummy node, not a dummy head. We'll create a dummy node. Linked list node is equal linked list is equal to new linked list. We'll get this dummy node. Okay, and then we'll make head and current point to the same node. Okay, so the first thing what you will do is, right, so we need to go on iterating. Two things you need to remember. So first thing, you need to go on iterating until, okay, before that I'll just put this is L2 and this is L1. Okay, so now what we do is we need to check whichever is, so first thing we need to remember is we need to go on until L1 and L2 is null, right? So if one of them is null, we need to step outside. So that is the first condition you need to remember. If one of them is null, you need to come outside the while loop. And the second thing is, okay, so let's see the code, you will understand. So we need to change the pointers and stuff, right? So what do we do? So we have L1 and L2 here. So I'll just write this one. So while L1 and L2 is not equal to null. So come inside. So if so here L2 is less, so L2 is less than L1. So in this case what we do is, so current, so we need to sort them in ascending order, right? So whatever current is pointing to, so we'll just make current dot next pointer, that is this one. Okay, this one will point to 1. Okay, this one will point to L2. So what we did, is current dot next is equal to L2. So after that we do L2. So now we are pointing to L2, right? So we do L2 is equal to L2 dot next. We put it in the, we just move L2. So L2 is equal to L2 dot next. So quick low code, let's put this here. Okay. So now current, so we need to keep track of this, right? So we are initially over here. So anyway, we need to be one step behind L2 or L1. So that's the second thing you need to remember. So we'll do, so after there is one else condition is here as well. So after we do if or else, right? Inside the while loop only, we do current is equal to current dot next. So we do current is equal to current dot next. So once we do this, we have, okay. So now coming back to this one. So now we have so L1 and L2 is not null. Okay. L2 is less than L1. 3 is less than 2. So this condition is false. So we need to write the else condition now, else we do the same thing. So what we do is current, so leave this code now. So leave it, let's, okay, we did this step. Now typically you want this one to come here, right? This current dot next should come here to L1, right? So we do the same thing, that only, simple. So current dot next is equal to L1, right? So this one will point to L1. Okay, so now how to, okay, so now this one will point to L1. Okay, so this one will point to L1, and then second guys, I'll just write this properly. Okay, so after that we do same thing what we did for L2, we do for L1 also. L1 is equal to L1 dot next. So L1 is equal to L1 dot next. Okay. So now current is equal to current dot next. So current is equal to current was here. So current dot next is pointing to 2. So current will come here. That's it. So now now again L1 is not null, L2 is not null, L2 is, so now we check, is L2 less than L1? 3 is less than 6. Yes. So current dot next will point to L2. Okay. L2 is equal to L2 dot next. We'll move this one here. Current is equal to current dot next. Current was here. It will come here. Now again L1 and L2 is not null. So L2 4 is less than 6. So this is correct. So current dot next. So current dot L2 4 is less than 6. So current dot next will come to L2. L2 is equal to L2 dot next. Again L1 and L2 is not null. L2 is less than L1. 5 is less than 6. Yes, correct. So current dot next. This is current dot next. It will point, current is equal to, so current dot 5 is less than 6. That's correct. So current dot next will point to L2. L2 is equal to L2 dot next. Current is equal to current dot next. Now L1 is not null, L2 is not null. L2 is less than L1. L2 is less than L1. So that's true. Wait, L2 is greater than L1, so it will come here. So current dot next will now point to L1. L2 is equal to L2 dot next. Current is equal to current dot next. Right? And next, again L1 and L2 is not null. So now again L2 is less than L1. Is it, is it, this is L2, this is L1. 10 is less than 6 is false. So current dot next is equal to, one second. So we have here current dot next is L1. Okay, I forgot to do L1 is equal to L1 dot next. Current is equal to current dot next. L1 and L2 is not null. L2 is lesser than L1. 9 is less than 7 is false. So it will come to else block. Current dot next is equal to L1. It's already pointing. L1 is equal to L1 dot next. Current is equal to current dot next. Now L1 and L2 is not null. L2 is less than L1. No. Current dot next is equal to L1. L1 is equal to L1 dot next. So this is nothing but null. So L1 will be pointing here. Current is equal to current dot next. So now again, so now we come here. Okay, L1 and L1 is null. We come out. So once we come out, so whatever after this one, we just need to join it here, right? So there will be two cases for this one. So either L1 will be null. In our case, here L1 became null, so we need to connect this one over here. Maybe in some other case L2 can be null, and we just need to connect whatever after this to L2. So in our case, so what we have to do is, if L1 is equal to null, we do current 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 dot next. Current dot next is equal to L2. L2 is here, we just need to put it here. L2 is already pointing to the right one. Current dot next is equal to L2. Else current dot next is equal to L1. That's it. So now this one will come here, and one last step what we have to do is, so here we have head pointing to this one. We just need to do head is equal to head dot next. So this is head. Head dot next. Head is next will point is pointing to 1. So it will just come here. So now we need to, so after this is step 1, this is step 2. So here so after that we just need to do a return head dot next. So that's all. So let's implement this solution. So like I said, step one, initialize. So yeah, this time complexity will be of n plus m. So n is the number of nodes in the first linked list, m is the number of nodes in the second linked list. It will be n plus m because like mostly like we need to travel through all the elements, right? Assuming the worst case. We need to traverse all the elements of both of them to get this linked list. So it will be n plus m. The space complexity will be of 1 because we are not using any extra space here. We are just changing the this one, the pointers. So the same thing, whatever we have learned here, let's implement this one. So step one, so step zero is uh, create this node. Okay, I'll just create that node here. Linked list head is equal to new linked list. I'll just give it a value of -1, some dummy value. So now we created head. Okay, we need to also create current also, like I said in the beginning. Current also should be pointing to this. So linked list current is also equal to head. So now so step zero over. So now step one, we need to do this. Okay. Same thing, I'll just put it here. So while L1 is not equal to null and then L2 is not equal to null. So if L2 dot value, we need to add L1, it has value. This is how the linked list is there. So we'll just add this one, L1 dot value, L1 by L1 and L2 is not null. L1 dot value is less than, wait, what did I put here? L2 dot value is less than L1. L2 dot value is less than L1 dot value. So current dot next is equal to L2. L2 is equal to L2 dot next. Else current dot next is equal to L1 and L1 is equal to L1 dot next. Okay. So now current is equal to current dot next. Okay. Current is equal to current dot next. This should be a part of this while loop. Yes, it is. So this is step one. Step two is, so I just add one ternary loop, ternary operator. So current dot next is equal to L1. L1 is equal to null is equal to null question mark current dot next current is equal to L2 current dot next L1 current dot next is equal to else current dot next is equal to L1. This thing is not aligned properly. So this file opens current dot next. Then is if L1 is null, current dot next is equal to L2, else current dot next is equal to L1. Okay, so return head dot next. So that's it. This is the code. Let's see if it runs. Okay, not 17. Linked list. Not find symbol. Linked list head is equal to new linked list. Link uh, next 19. That L1. Yeah, I'll just change it up here. L1, L2, 25, E, and T. And current dot next is equal to L1 is null. Okay, check with this. L2, fill is null. So whatever I have written here, you can put this if block also. L1 is null. Okay, current dot next will be L2, or else it will be L1. Return head dot next. Yes. So guys, this is the solution. So hope you understood this detailed explanation. So yeah, then like I said, the time complexity will be of n plus n, where n and n is the total number of nodes in both the linked list, and space complexity will be O of 1. So yeah, that's it. Thank you for watching.